We've now got a pretty good idea of some of the basic syntax around maps, but the burning question that's probably still sitting in your head is, hey, how is this different from structs? Like structs looked really similar. We defined some property name and then assigned it some value. So how are structs and maps different? I put together a little diagram that's going to kind of compare and contrast some of the differences between these two data structures. So let's take a look. Now there's a lot of differences here, but we're going to go through them one by one. So we'll first start off with some of the very obvious properties, and then we'll talk about some of the more kind of interesting differences between maps and structs. So first off, most obvious difference here between a map and a struct is that with a map, both all keys must be of the same type and all values must be of the same type. A struct is distinctly different because in a struct, all the values can be of completely different types. Now notice here that we're saying values can be of different types because in struct, or with a struct, excuse me, the keys are not strongly typed. We interact with those keys by defining the key names ahead of time or the property names ahead of time, and then we access them using that familiar dot syntax. So difference number one to be very aware of is that all the keys and values with a map must be the same type, but with structs we can mix and match different value types if we want. The second big difference is that with the map, all the different keys are indexed. So by indexed, I mean to say that with a map, we can iterate over all the different key value pairs inside of a map. But the same is not true of a struct. So with a struct, we cannot iterate over all the different key value pairs or all the different properties inside of one. Now, one of the other big differences, and this goes back to our discussion about pointers in Go, is that a map is a reference type, whereas a struct is a value type. So remember what we had said about reference types and value types when we were discussing pointers? Essentially, this means that when we pass a map off to a function, we are passing off a reference to the underlying data structure. So if we pass a map off to a function, just like we did right here with print map, you'll see that we didn't say anything with colors. You don't see any ampersand here, you don't see any stars, nothing like that inside this code. But if we made a change to print map, or if we made a change to our map inside of print map, then the underlying data structure, colors over here, would see that update. So when we pass this map off to the function, we are not copying the map, we are copying a reference to the map. Now that's distinctly different than our interaction with structs, where if we passed a struct off to a function, we made a copy of the entire struct. And so if we changed the struct, it did not modify the original one that we had created outside the function. So one thing that you're probably curious is, well, okay, I get some of these differences, I understand them, but where do I use one data structure as opposed to the other? Well, in general, and this is some very high-level guidance because it's kind of tough to give you just very solid rules and say, oh, use a map 100% of the time here or use a struct 100% of the time here. Just some very general guidance is that you'll want to use a map whenever you're representing a collection of very closely related properties. And so the code example that we just put together was actually a great example of that. So right here, we put together a collection of key value pairs that represented the mapping between a color name and its hex code representation. And so these are some very closely related values that all had some very significant meaning to each other. This is very closely related to one of the other big differences between a map and a struct. And that is that with a map, we do not need to know a list of all the different keys or all the different field names at compile time. So with a map, we were freely able to create the map right here, and then we could add and remove properties, like say, I don't know, yellow or what have you, over time as we please. And then we can delete it immediately after. And that's an example that we just saw 2 seconds ago. But with a struct, we have to very clearly define all of the different property names and all of their types at compile time. Like we have to very clearly list out all these property names. And so if you're thinking that you are creating some type of relationship between some keys and some values, and you don't really know what that collection of values are going to be, or what that collection of keys are going to be at compile time, like as you're writing your code, well then chances are you've got a great use case for a map. But if you've got some closed set of keys, like for example, if you know that you are always going to be working only with the keys red, green, and white, well, then maybe you have a case where you might want to look at using a struct. Now, over time, as we start to write some more complex programs, we're going to get a little bit more experience with maps and structs, and so we'll be able to point out where some cases it's a great use of a struct, and in some cases maybe it's a great use of a map. Now, I will say that in the vast majority of kind of professional level Go code that I've written, I usually end up using structs a lot more than maps, but again, it really just comes down to the type of application that you're building. Okay, so I think that we've got a better sense of what maps are and some of the differences between a map and a struct. So I think that we'll take a quick break right now, and we'll maybe have a quick quiz or two just to kind of drill home some of the aspects of maps and some of the important aspects of them. So let's take a quick break, we'll get to that quiz, and then we'll continue with our next big topic in the next section.